Good day and welcome once again to the Math Salon. I'm Dr. Numende. Today we'll be looking at matrices. This is for the advanced levels. Of course, the idea also applies to O levels. It's just that at math levels, you don't go to the dimension of 3 by 3. You always end at the 2 by 2 matrix. And the 2 by 2 matrix is much more easier than the 3 by 3. And matrices are applied in different domains, different fields. Medicine can be applied to business and different domains. But in this context, we will look at the question model for the advanced level examination. So if that is the case, the question that we have here at hand is, given that we have a matrix A given as this, and a matrix B given as that, find A multiplied by B and B multiplied by A, and state the relationship between A and B. And if you're also given for the second part that the matrix M is given like that, find Bm and solve the system of equation that. Before we proceed, I think we'll make a recap. Let's go back a little, some years back in your studies. With the idea of dividing, actually is only well defined with multiplication. So for example, if I have 8 divided by 4 and I say the answer is 2, what I actually mean here is that in order to get 8, you need to multiply 4 twice. That is the idea. So that is the notion of division. On its own, it doesn't make sense. You have to use the idea. Just like addition and subtraction. Subtraction, you don't need to define it because it's just adding with a negative number. So if I have something like 2 divided by 2, you all know the answer is 1. That answer is 1 because we see that to get 2, how many times do you have to multiply 2? You just have to multiply 1 time, and that is the case. This would mean that a number when multiplied by 1 does not change. So if I multiply you by 1, you don't change. Yeah, that's just a joke. Don't go around multiplying people by 1. So what we will do here is I will play a little as we normally do in our math salon. So I'll write this 2 times 1 all over 2. So the denominator can be played around to be written this way, and this is still equal to 1, and I will say this is 2 times 2 from indices, this is 2 to the minus 1 is equal to 1. So that we look at this looks like the inverse of this one, at least in terms of numbers and numeric. So I can say in general, if we have our any numbers, then a times a to the minus 1 will always be equal to 1. This is just a single number. So if we look at the matrix, this is a collection of numbers presented in the form of rows and columns. So in that case, division is best defined when we use the idea of inverse instead of trying to cancel out, as we know. That means if I have like A divided by A, this is now not equal to 1 because this is a matrix. So my answer should also be a matrix. So we have a matrix version of the 1, which is also still the idea of identity, which means it doesn't change. So I have to look for a matrix here, which when multiplied by A does not change. So if I multiply you by the identity matrix, it don't change. Still a joke. So then we'll call it I here. But then we can write this as A multiplied by A to the minus 1 is equal to I, where this is a matrix and that is its inverse. So if two matrices are multiplied and you get an identity matrix, then one of them is the inverse of the other. That is the concept. Let's go now to our problem. So to solve the question now, the idea is, of course, we have to look for A multiplied by B. So I just copy my matrix A here and I put it here. The matrix B, I copy and I put there. Now is the multiplication. Many students do forget how to multiply. For example, when you take this row, it has to match. So the number of columns of your first matrix must match the number of rows of the second matrix before you can multiply, before it's possible to do that. So here, of course, I have 3 columns here and 3 rows, so I can multiply. So when I take this row and multiply with this column here, I get the first entry of my answer, the first entry. So I take, for example, 1 times 3 is 3. Minus 1 times minus 2 is plus 2. 1 times minus 4 is minus 4. That's the first entry there. I take this, I multiply with the second one, and I get this part. So I get this. So 1 times 3 is 3. Minus 1 times minus 2 is plus 2. 1 times minus 5 is minus 5. I take it again, and I multiply with this one to get the third one. 1 times minus 1 is minus 1. Minus 1 times 1 is minus 1. 1 times 2 is 2. When I go to the second one, I'll use blue ink there. I do the same thing. Maybe a different color. Maybe. I do the same thing here. I multiply with this, I multiply with that, I multiply to get this second line here. I think I should get a different color. Do I do red? This red is not too good. Yeah, anyway, sorry about that. Could not really find some. So you get the next one there for this one. So when this one does that, you go to the next row and so forth. So here, 0 times 3 is 0. 2 times minus 2 is minus 4. Minus 1 times minus 4 is plus 4. And 0 times 3 is 0. 2 times minus 2 is minus 4. Minus 1 times minus 5 is 5. 0 times minus 1 is 0. 2 times 1 is 2. Minus 1 times 2 is minus 2. You will do that also for the third row there. Once that is done, then it's left to simplify. If I try to simplify that, say 3 plus 2 is 5. 5 minus 4 is 1. 3 plus 2 minus 5, this is 5 minus 5, that is 0. Minus 2 plus 2 is also 0. Minus 4 plus 4 is 0. Minus 4 plus 5 is 1. 2 minus 2 is 0. 6 minus 6 is 0. 6 minus 6 is 0. Minus 2 plus 3 plus 0, 3 and minus 2 there is 1. So I get here, this is an identity matrix, a 3 by 3 identity matrix there for this. So it already gives me some ideas that, yeah, by the rule I just indicated, one of these should be the inverse of the other, say. And if that is true, then your commutativity works, which means that if a matrix multiplies its inverse to get a random element, then if you reverse the order of the multiplication, you will still have the same answer. So now if you multiply B times A, I just take the matrix B, I put it before, and the matrix A I put after. If I do that, I would do exactly the same way I already explained to you there. I would take this, I multiply by that to get the first entry there, I multiply by this to get the second entry, I multiply by that to get the third entry. Maybe we just check that that is true. 3 times 1 is 3. 3 times 0 is 0. Minus 1 times 2 is minus 2. 3 times minus 1 is minus 3. 3 times 2 is 6. Minus 1 times 3 is minus 3. So if I do that, I can also take the second row and do the same thing, the third row, and get all my entries. If I simplify that, for example, 3 minus 2 is 1. This is minus 6 plus 6 is 0. 3 minus 3 is 0. We get again an identity matrix, a 3 by 3 identity matrix. Sometimes you can write 3 there below to say that is the order, 3. If this is true, then the relationship between A and B is that B is the inverse of A. That's what you have in your mind. That B is the inverse of A here. So actually B is equal to A inverse. That's the relationship. So that this expression of AB can now be written as A times A to the minus 1, and that is I, which is true, which is what we just saw here. The second part of the equation says, given that M is given as 8 minus 7 and 1, find the product BM. This is my B here, 3, 3 minus 1 minus 2 minus 2, 1, and that is M. So we are just left to do a multiplication. The number of columns must match the number of rows. There are 3 columns here and 3 rows here, so it's going to work. And the dimension of your answer is always the dimension of the second matrix when you do multiplication. So here, this is 3 times 8 is 24. 3 times minus 7 is minus 21. Minus 1 times 1 is minus 1. So if you take this and multiply, you get the first entry there. And if you take this and multiply, you get the second and you get the third. Now, just to simplify that, we have 24 minus 21 minus that is 2, because this is minus 22. And you get minus 16 plus 14 plus 1, that is 15, minus that as minus 1. Minus 32 plus 35 plus 2, so that is 37 minus that, and that is 5. So this is my answer for B multiplied by M. I will erase the board and then we will look at the second part. I leave what we have below there because you're going to borrow some inspiration from there. So once you are given a system of equations to solve, the most important thing is to try to arrange them well so that your columns are properly arranged in terms of the variables that are there. For example, my first column should contain all x's and the second column y and then the third z. So if I rewrite this, then I will say this is x here minus y plus z is equal to 8. And then 2y minus that, it means there is 0x here because there's no x in that equation, so I can force it so that my columns are well arranged. And then plus 2y minus z is equal to minus 7. And the last one is 2x there plus 3y. There is no z there, so I also force the z. 0z is equal to 1. Because I know when you multiply a number by 0, it's 0. So it doesn't matter. We just use a beautiful 0 as we do in our saloon. This is now is well arranged, but we have to make it, let it be in matrix form. And what we do is we pick out the coefficients and form a matrix out of them. So the coefficients here, we have here 1, 0, 2. Here is minus 1, 2, 3. Here is 1, minus 1, 0. In order that the system remains valid, we also create a column matrix here so that when we open, we're going to get exactly the same relationship as the original problem, the system of equations we got. So if that is true here, then it means that, yeah, if I open this, 1 times x is that minus y plus z, you get the first one. You do that, you get the second. But then you recognize that this matrix is exactly like A. You see, this matrix is exactly like A. So I will call this A and call this one x and say that is equal to, let's say, C for this one. So this is A here, this is x, and this is C. When we have to solve, you already learned, if you have something like 2x is equal to 3 and they say solve for x, what you do is you divide both sides by 2. And then you say answer is equal to 3 on 2. But because these are matrices, we cannot divide like that. I just indicated to you. We need to apply the idea of inverses. So in order to solve for this x here, I have to multiply both sides by the inverse of A. So which means my A xc equal to C is like A times A inverse x is equal to A inverse C. You can put it anywhere. We already showed that it's commutative. It can be A inverse A and the other way, that's fine. But we know that if you do this, this one becomes I. We've already seen that a matrix multiplied by its inverse gives you an identity matrix. An identity matrix means it doesn't change the matrix that it multiplies. So this is A inverse C, and x by identity is just x. So to get these x's, which are the solution of this system of equation, it just simply means take A inverse, take this, the inverse of this matrix A, and multiply by the constant that you have here. We already saw that A inverse was the matrix B that we saw before. So this is actually B here, because we saw that B was equal to A inverse. I showed you that, or that was at least the relationship we established. So in the place of this A inverse, I will put B. But C, if we look at this C well, this is exactly M. This is the matrix that we have M. So my C is equal to M. And then this is Bm. So it means, and we already did, the product Bm. So my answers are just 2, minus 1, 5. For the x's, remember this x is a big X matrix, which is small x, y, and z. So my small x, y, z is equal to 2, minus 1, 5. So this simply means x is equal to 2, y is equal to minus 1, and z is equal to 5. Hope you understood it. We took quite some time to go through. It was a laborious process, but I think it's worthwhile. It's important that you do remember to share with your friends, discuss in groups, and if you have some comments, leave them on my Facebook comments, and I will check and see how I can improve on that. Remember to give us some thumbs up, subscribe, encourage your friends to subscribe so that if we upload new videos, somebody will get an alert and will indicate to you. I will try to do much more in the future. Bye.